Hey there, welcome back to another video with the Math Doc. We are still talking about linear functions as part of the function unit. And in this quick video, we will define and look at what the slope of a linear function is. And in the previous video, where we talked about what a linear function is, we spoke about a constant rate of change. And if you haven't checked out that video, check it out because it goes into detail about what makes a linear function a linear function. In this video, I just want to talk about another term that is used when we talk about linear functions, and that is the slope. But the slope is really exactly the same as a rate of change. They are used interchangeably. The main difference is that the word slope is kind of familiar to us from our physical word, so it's good to use that word a little bit as well. And we define the rate of change as the difference in the y, so that would be the difference in y values, divided by the difference in x values. And as a reminder, we also spoke about the fact that x's are our input values, y are the output. The input comes from the domain of the function, that's the term we use, while the output has to remain within the range of the function. So these were the terms we already learned, and we're just including the term slope now, which is another word for rate of change. And let's just look at this example and use that word slope rather than rate of change in order to get used to it. So when we look at the slope of a linear function, which is again a straight line, right? Linear function means that when we draw the function, we will see a straight line. So when we look at this straight line here in red, I have emphasized a few points, and we'll use these to identify the slope. So for instance, we're going to look at a y2 and an x2. That will be, say, this point here. So y2 is 7 minus, and we're going to put in a y1 in a moment, but in the denominator our x2 is just 4, right? So we can look at our axes, 7 and 4. Okay, now what is going to be our second point? Let's look at the point, say, when x equals 0 down here. So our x is just 0, and our y is 1. So y1, so this was y2, now y1 is going to be 1, and x1 is going to be 0. So I don't want this to be confusing. That is the y, that's the x, and that's x2. So we have 7 minus 1 divided by 4 minus 0. So we looked at the slope as we can calculate it between these two values here. So we have 7 minus 1 is 6, 4 minus 0 is 4, 6 quarters is exactly 3 halves. So our slope here is 3 halves. Now in the previous video we emphasized that for a linear function, the rate of change, or the slope, is constant, which means that if we look at two other points, we should see the same slope. So let's do that. Let's look at, say, this point here. So we have a point at x equals minus 2, and our y here is also minus 2, right? Here and here. And let's look at, so we'll write this as our y2 minus 2 in the denominator, and x2 will be minus 2 as well, and we do minus. And let's look at this point here where we have x equals minus 4, right, up there, and y equals minus 5. So x equals minus 4. Remember, the x goes in the denominator, and y equals minus 5. So what do we get here? We have some, we're looking at the difference with a negative number, so we have to remember that minus is just plus. So we have minus 2 plus 5, or negative 2 plus 5, divide by negative 2 plus 4. That equals, on top, well, let's change the order, the commutative law, right? 5 minus 2, and the same for the denominator, and we get 3. 5 minus 2 is 3, and 4 minus 2 is 2, so again, we get a slope of 3/2. So the slope here is equal to 3/2. So this was just a quick video to introduce the word slope and remind you how to calculate rate of change, which is exactly the same thing as slope. We will be talking more about the slopes of linear functions, so it's good to get the term well integrated into our language when we talk about linear functions. So thanks for joining me again. If this video was helpful, please like, comment below if you have questions or comments, and I will see you next time.